brain-machine interface is a system that allows people suffering from physical disabilities to communicate with the external world and also to control devices. What we are doing is measuring the spontaneous activity of the brain, electrical activity of the brain, and trying to detect patterns that are associated to different intentions. For example, if I imagine moving my right hand, this will generate a specific pattern of activity in my brain. Now, if we develop the software that can do the real-time analysis of what is going on in my brain, I can detect that particular pattern and transform that pattern into some external action.
Welcome, generous viewers, to this week's edition of Golden Age Technology. In part 2 of our two-part series, we continue to examine some of the latest applications of brain-computer interface, or BCI technology, to better the lives of the disabled. Last week, we learned about some of the research in this field being conducted by a team of scientists and students at the renowned Swiss university École Polytechnique Fédérale de Lausanne, led by Dr. José del Rocio Millán, DefiTech professor at EPFL. The team is developing devices that are controlled by the brain's electrical signals, such as an electric wheelchair, a telepresence robot, or a robot that acts as the user's eyes and ears in a remote location, and a neuroprosthetic limb. The signals are transmitted to the computer via a cap that the user wears.
The idea of the cap is that we place these electrodes on the top of the scalp, and these electrodes record the activity of the brain, and these signals are super small. We are talking about the order of microvolts. So imagine it's very tiny. And when you deal with such small signals, actually it's very important that your scalp can conduct very well this electric message. If you have short hair, your skin is much more exposed to the atmosphere, so the signals are actually worse. So the longer the hair, the more protected the scalp is, the better signal, the better BCI control.
Professor Millán is coordinator for a project called Tools for Brain-Computer Interaction, or TOBI, a collaboration of major European scientific research and medical institutes involved in the field of BCI research. Since 2008, the TOBI project has strived to develop non-invasive methods of BCI technology that improve the lives of the disabled and the effectiveness of patient rehabilitation. Although Professor Millán and his team continue to make great progress, much work remains to be done. For instance, it is not realistic to expect users to maintain the high level of concentration currently needed to operate the brain-computer interface devices over extended periods of time, as it is tiring and other tasks need to be performed by the user as well.
It has taken us many years of research to develop the software and the principles behind that facilitate the training, the understanding, the recognition of the intention of the person, and the translation of those intentions into the control of sophisticated devices. The limitation is that people cannot sustain for a long period of time the necessary degree of attention. And also they need to keep focus on delivering the appropriate mental command at any time. What we have been doing is to develop new algorithms in order to better analyze the brain signals, and also to develop principles, for example, on how to combine the intention of the person with the use of intelligent machines that will facilitate the operation, especially over long periods of time. The critical point here is how to allow people not just to control the wheelchair for 5 meters, but for 5 hours in a row. What we want is to bring this technology out of the lab. And this has 2 components. First is testing with real patients, so as to demonstrate that this is a feasible technology that they can benefit from. And to do so, we are engaged in a large European project. And the second aspect of that is to guarantee that they can use the technology over long periods of time. And for doing so, we are working in different aspects of the technology, scientifically addressing how to make possible that people can communicate at different paces depending on their needs.
Last week, we learned about the exciting evolution of a BCI-controlled wheelchair, a major focus of the work being carried out by Professor Millán and others. Now let's look more closely at a few other devices under development at EPFL.
What we have done is couple our brain-computer interface with an assistive technology software, and in this case QualiWord, provided by QualiLife, so that the user is able to provide mental commands to the software so that he can browse the web or even type a message and convey words to the external world. So it works by providing mental commands to external devices such as a virtual keyboard or a mobile robot. The user has to think of specific movements of his limbs, and these movements create specific brain activity patterns on his scalp that we identify by signal processing techniques and by means, of course, the hardware and electrodes we use that are placed on the user's scalp. And eventually we associate the identification of these movements to specific commands for the external device. Well, we mainly target disabled people that suffer from amyotrophic lateral sclerosis or spinal cord injuries, and as a result they can barely or they cannot move. So, of course, we also target healthy users, mainly for entertainment applications, like controlling your computer without moving at all.
Incorporating his expertise in brain-computer interface and intelligent robotics, Professor Millán is helping to create a BCI-controlled telepresence robot through which a user can remotely interact with others.
Brain-machine interface allows disabled people suffering from physical disabilities, to operate, for example, these robots, to drive it to where the family is and participate in the daily social activities. To operate such a kind of complex device through a brain-machine interface is feasible. A patient was exploring our lab. He was controlling this telepresence robot from a clinic 100 kilometers away from our lab. Essentially, he was able to do the same experiments as healthy volunteers did, with a performance that is essentially the same as healthy people.
Another BCI-controlled apparatus now under development at EPFL seeks to give disabled users the ability to accomplish everyday tasks, such as picking up items or writing with a pen.
We are targeting people who have some residual functionality at the level of the elbow and the shoulder, so that they can still position the arm, but what they miss is the capability to grasp. So what we want is to restore the grasping functionality, for example, using this kind of orthotics that will facilitate the grasping, will make it more stable, more uniform. I will not enter into the details of that device. But the important thing is that we want to achieve a natural interaction paradigm, in the sense that if people want to control the left hand, they need to concentrate on the imagination of the left hand.
Once released, the important new technology from EPFL Labs will likely enhance the disabled's quality of life and aid patients undergoing physical rehabilitation therapy. And aid Millán to estimate how long it may be before these beneficial innovations become available to the public.
Making a projection of when this technology will be available for patients for their daily use on the market, this is a delicate question. We are at the phase of testing our prototypes with as many patients as we can, especially in the framework of an European project that I am coordinating that is called TOBI. But we don't have yet enough evidence that sophisticated neuroprosthetic devices are yet mature enough to bring them to the market. So the key point here is that we need to be sure that these systems are robust enough and will only be able to gather this information through extensive clinical trials. So how long this will take, I cannot anticipate. I hope that in 10 years from now, but I cannot give a more precise indication.
It is also possible that the technological advancements made by Professor Millán and his team will eventually be applied in other fields.
Professor Millán, can this technology be used for other purposes?
Our main target is to help disabled people who are suffering from physical disabilities. But it is true that once this technology is mature enough, we can think of helping able-bodied people who may eventually suffer from what it is called situational disabilities. This is, for example, the case of astronauts in space, where they don't have a normal control of their body because of the absence of gravity. Yet, even in space, the brain processes work as on Earth. And we have shown that people can operate the BCI under the absence of gravity.
Professor Millán and other scientists at École Polytechnique Fédérale de Lausanne, you have our respect and gratitude for your dedication to bettering the lives of the disabled by furthering the development of brain-computer interface technology. We pray that the day will soon come when the BCI-controlled life-enhancing devices like the ones you have designed will be widely available to those who can benefit from them. For more details on Professor Millán, please visit people.epfl.ch/Jose.Millán. More information on the Tools for Brain-Computer Interaction project is available at www.toby-project.org. Talented viewers, we appreciated having your company today on Golden Age Technology. Coming up next is vegetarianism, the noble way of living. After noteworthy news, may everlasting peace and happiness be known by all.
For more details, please visit www.suprememastertv.com/GAT